Hello everyone, welcome back to 6.4 Equations with Rational Expressions and Graphs. In this section we are going to talk about graphing and what the graphs of rational functions look like. Now, one thing you need to know about rational functions is they're often discontinuous, and what that means is there are gaps. There are gaps in the graph. So there's going to be spots where the line does not go. And there's going to be holes, so to speak, where as you're drawing a graph, all of a sudden it zooms up or it zooms down and it stays away from certain values. Okay, so like we do with everything, graphing is all about inputting values of x and seeing what you get for y. So if I go ahead and look here, I created a table, and you can use any values you want for the x values. Okay. So I go ahead and pre-populated this with -3, -2. You like to have some negatives and some positives all together, okay? So what I'm going to do is I'm going to use this space right here, and I'm going to ignore the domain and the range for now. And I'm just going to show you what it looks like when you input these values into f of x. So the first value is f, and we're just choosing -3 to start. So I'm going to put f of, let me get this set up, f of -3. So as I put in -3 in for x, what does my value ultimately become? Well, it becomes -1/3. Okay, so if I go over to the graph, I should be able to go to the graph, go to -3 for the x value. This is -3. And my y value, 1, 2, 3. And this is just an estimate. My y value is going to be -1/3. So it's going to be very small. I need to go into the negative direction also. 1, 2, 3. It's going to be very small, 1/3. So 1/3 looks about here. It doesn't have to be exact for this particular exercise. Then I'm going to write -1/3. Now we're just going to repeat this process. So now I'm going to pick -2 for my input for x. -2. And this one is pretty simple because as soon as you put in the x value, you have your result. So in this one, it's -1/2. So if I go over to the x value of -2, I'm going to write it above the line, as you should. I go to -1/2 for my y. So it's a little below that. Okay, and this is a pattern. If we keep this up, okay, so now I'm going to input -1 in for x. What do I get? I get -1 for y. So now I'm a little bit lower. Okay, so -1. Now I'm going to put in -0.5 or -1/2. I'm going to write it as -0.5, -0.5. So 1 divided by -0.5. A lot of people might think, oh, it's 0.5. That is incorrect. Remember, when you divide by a fraction or a decimal, it ends up becoming multiplied because you keep change flip, you're going to end up by multiplying by the reciprocal, okay? So this actually becomes -2. So for the input of -0.5 for x, you get -2 for y. And that's about there, okay? Now, I didn't write 0. Why did I not write 0? Well, what happens if you input 0 for x? I put 0 for x. I get 1 divided by 0. That is undefined. Okay? You can't do that. So we're actually going to see that we're going to have a gap at the x value of 0. So I'm going to go ahead and do that with my highlighter. I'm going to get the color pink just so it stands out a little bit. And I'm going to show you that this is a line that does not the line does not cross, or the line does not have a value there. The function does not have a value there. Okay, now I'm moving on to the 0.5 size. I'm going to do a couple just so you can get the idea. So as I put +0.5, I get +2 for my y value. Okay, so I need to go over into the positive x values. So, and it looks like I'm going to have just the opposite effect. Okay, so as I put in 1, I'm going to get the value of 1. As I put in 2, I'm going to get 1/2, and then I'm going to get 1/3. So it's going to look something like this. Okay, and if you did a lot of points and put a lot of values in, you would get a function that looks something like this. And I know I didn't connect the dots perfectly, but you're just getting the idea. Okay, sorry, a little struggle at the end there. Okay, this is the graph of the function 1 over x. Okay, now notice two things. One, it avoided this line here, and anytime a function does not cross a point, but it approaches, see how it's getting closer and closer to that line? Okay, that is called an asymptote. Okay, it's a spot where the function does not go, but it approaches infinitely. It gets infinitely close, but it never gets there. Well, where do you see another one on this graph? There's another one, I'll use purple, right here. If you can see, this graph will never, ever be equal to 0. And think about it this way. Okay, what values could we put in for x to make it equal 0 on this side? So if we wanted our y value to equal 0, we put the 0 in there, boom, 0's in. How could we make it equal 0? What could we put in for x to make that equal 0? There are no values. If you put in 0, it's undefined. If you put in 1, then you get 1. So there's really nothing you can put in there. So that's why there's an asymptote both at the y-axis and the x-axis. Okay? And that's where y equals 0, and that is x equals 0. Those are the equations of those asymptotes. Okay? So our range then becomes, well, what are the, or excuse me, domain. Our domain is the possible x values. So it goes all real numbers, okay, because it goes all the way to the left infinitely, and it goes all the way to the right infinitely, except 0. X is not equal to 0. Now let's think of our range. Where does our range go? Let me erase this. Okay, well, our range goes infinitely down and infinitely up, but there's a gap also with the range. It's where y is not equal to 0. So our range is all real numbers, y not equal to 0. So we defined an asymptote. We know what that is now. That is a line where a function approaches but cannot equal its value. Okay, so it approaches, but it can't be equal to 0. It approaches the x-axis or the y-axis, x equals 0, but it cannot be equal to 0. Okay, I think we can continue with these definitions real quick. And this is just kind of technical. You don't have to be super concerned about this, but it's important to know just in case. So a vertical asymptote, if the x values approach infinity or negative infinity as the, if the y values approach infinity or negative infinity as the x values approach a real number a, the vertical line x equal a is a vertical asymptote. Okay, so we saw here that the y's were approaching infinity this way. See, they're approaching infinity. Here they're approaching negative infinity. Okay, so the value of x is a vertical asymptote. It can't equal that vertical line. That's why it's stretching out and not touching it. The opposite is kind of true for horizontal asymptotes. If the y values approach a real number b, as b, the absolute value of b increases but can never reach b, the horizontal line y equals b is a horizontal asymptote. So actually I need to change this to x values here. Sorry, getting these mixed up. So the x values. So here we're looking left and right. This gets to negative infinity. This one gets to positive infinity. And notice how they do not equal it, so it's a horizontal line.